Hello, everyone. Our previous video was on summarizing skewed data with the median and IQR. We're going to go ahead and finish up the standard 4 slides, where we look at summarizing symmetric data using the mean, variance, and standard deviation. The mean, or average, is the center point in which a histogram would be balanced. It's the weighted average of all the different data points in a sample. So I'm sure we all know how to find the average of a data set. You add all the values up, then you divide by the number of numbers in the data set. Using some of the statistical notation, y bar is the notation for average, and y bar is equal to the summation of all the data points y divided by the sample size n. An interesting question down here: which is more resistant to outliers in a data set, the median or the mean? Well, let's investigate that a little bit further. Say I have no outliers. I have a perfectly symmetric data set. An example of that pretty quick: 1, 2, 3, 4, 5. The mean and median are each 3. The mean is found by adding all these up. 1 plus 2 plus 3 plus 4 plus 5 is 15. Divided by 5 makes 3. The number in the middle, the median, is also 3. Now let's skew this data set. 1, 2, 3, 4, and now instead of 5, let's do 25. Now this is a right skewed data set with majority of data falling on the low side, with one outlier significantly higher than all the rest of the data. Which measure of center, mean or median, is most affected by this outlier? Well, let's go ahead and find the mean and median of this data set. The median is still 3, the number in the middle. If I add 1 plus 2 plus 3 plus 4 plus 25, I get 35. Divided by 5 makes 7. The mean is not as resistant as the median when it comes to outliers. It's changed by adding that 25 instead of the 5. The mean is less resistant, the median is more resistant. In a right skewed distribution, the mean would be greater than the median, like we can see here. In a right skewed distribution, mean is greater than the median because that 25 pulls it further ahead of the median by adding 25. In a left skewed distribution, where I have an outlier on the significantly low side, it's just the opposite. The mean is less than the median. To summarize skewed and symmetric data sets, for symmetric data, we use mean and IQR. The data is best summarized using mean and IQR. For skewed data sets, we want to use the measure of center and spread that are more resistant, that are not as significantly impacted when it comes to those outliers because the data is skewed. In this case, we'll use the median and the IQR. Sorry, let me change that here. For symmetric, it needs to be mean and standard deviation. Pardon me. In our previous video, we looked at how to summarize using median and IQR using box plots. We're going to look at mean and standard deviation here in symmetric data sets and how to summarize and calculate those types of values. All right, so we've found the mean. Let's talk about variance and standard deviation. The variance is the average difference from the mean. Average difference from the mean. Notation for variance is S squared. S squared is equal to the summation of the differences from the mean squared divided by n minus 1. So I take a look at all the differences in each data point from the mean. Whether it's above or below, those differences could either be positive or negative. I want to accumulate all those differences, so I don't want to add the positive and negative differences together. I need to make them all positive. So let's square them. Now I've got all the squared differences. To find the average, I add them all up and divide by not the sample size anymore, not the number of numbers. We're going to divide by one less than that, n minus 1. A sample has what's called the degrees of freedom. And in a sample of size n, we have n minus 1 degrees in freedom. The reason is we've taken a sample, so there's going to be some error. Those errors can be accounted for by the variation, the differences from the mean. So I want to have more error than I would in a population because I've taken a sample. So I'm going to divide by a smaller number, n minus 1 as opposed to n. Another explanation would be if I have a data set of size n and I tell you the average, you would only have to know n minus 1 of those data points to figure out what the last one would be. So for example, if there is a data set with 5 different values and you're told the average, once you know 4 of them, the 5th one can be found pretty easily. There are n minus 1 independent values in a data set, and then the last one is dependent. In a data set of size 10, 9 independent values. Once you know 9, you can find the 10th one pretty easily, so long as you already know the average. That comes to the degrees of freedom. Standard deviation below is just the square root of the variance. You see how we squared all of those differences? So to get it back in terms of the original units, to get rid of the squaring, because I made those differences so much bigger than I needed to be, to make them all positive by squaring, I'm going to have to square root. So S for standard deviation notation is equal to the square root of the variance, S squared. All right, so let's go ahead and find the mean, sample variance, and sample standard deviation for the data set below, and we'll use technology to confirm our results. We're going to need to go ahead and figure out what y bar is first. What does the sample mean? So if I add all these up, 34 plus 41 plus 48 plus 51 plus 55 plus 58 plus 63 plus 74, I get 424 divided by 8, the number of numbers, 53. So S squared is equal to the summation of y minus y bar, the sample mean, squared, divided by the number of degrees of freedom, n minus 1. We found the mean. Let's use this formula to find the sample variance. We need to figure out the squared differences from the mean. So let's take 34 minus 53 squared, 41 minus 53 squared, and so on. So 34 minus 53 sure I have this right here, would be negative 19. I want to have all these differences positive so that when I add them together, it's a running total of the differences. So I'm going to square it. That's 361. We're going to do this for all the remaining data points. Find the difference from the mean squared. 41 minus 53 would be negative 12. Squared is 144. 48 minus 53 would be negative 5 squared equals 25. Okay, let's go ahead and keep working here. Let's see, 51 minus 53 is negative 2 squared, which is 4. Now we're going to be above the mean. 55 minus 53 is 2 squared, which is 4. Whether I'm above or below the mean, I'm still different from the mean. So in order to make sure that all these differences are positive, we had to have squared them. 58 minus 53 is 5. Squared makes 25. 63 minus 53 is 10. Squared makes 100. 74 minus 53 is 21 squared, which makes 441. Looking back at our formula here, we've now got this part done. We've got the differences from the mean squared. Now I'm going to add them all up, find the summation, and then divide by the number of degrees of freedom. In this case, I have a data set of size 8. So we'll have 8 minus 1 or 7 degrees of freedom. So we're going to add 361 plus 144 plus 25 plus 4 plus 4 plus 25 plus 100 and 441 to make 1104. So our sample variance is 1,104 divided by not 8, but 7. 7 degrees of freedom. And I get 157.71. All right. The hard work is over because the standard deviation is simply just the square root of 157.71. 12.56 approximately. We squared all these differences from the mean, so in order to get it back in our kind of regular units, I have to square root to cancel out the squaring. Which means that our data set on average is equal to 53, or differs from that by about 12.5. Now we can use Desmos or some whatever technology you want to go ahead and find the mean, variance, and standard deviation. I've got all of these values typed in to what I've called set A. The mean of A is 53. The variance, VAR, of set A is 157.71. And the standard deviation of set A is that 12.56. We use mean and standard deviation to summarize symmetric data as opposed to skewed data, which are best summarized by median and IQR. Because mean is not quite as resistant to skew as the median is, as you see. Okay. Let's go ahead and wrap this up with a quick practice question. Shown below are the histograms and summary statistics for the number of campsites at state parks in Iowa. So as you can see here, we've got the histogram. Looks like it's going to be a right skewed histogram on the high end, and most of the campsites in the state parks have about, I don't know, anywhere between 25 and 75 or so. Summary statistics are shown below. We have 46 state parks with an average of 62.8 campsites per state park. The median is 43.5 campsites. The standard deviation is 56.2 campsites. The minimum is 0. Maximum is 275. The lower and upper quartiles are both 28 and 78, respectively. So for part A, which statistics would you use to identify the center and spread of distribution, and why? Well, since this is a right skew distribution, we want to use the measures of center and spread that are most resistant to skew. So it could either be median and IQR or mean and standard deviation. And as you've seen, median and IQR are the best summary for this data set because it is skewed. Part B says, how many parks would you classify as outliers? This is found using fences. So the upper fence and lower fence. And as a review from our previous video, the upper fence and lower fence are the quartiles plus or minus 1.5 times the IQR. So for the upper fence, we'll take Q3, 78, plus 1.5 times the IQR, which is 78 minus 28, or 50. So 78 plus 1.5 times 50 is 153. $153 is about right here. I'm sorry, right about here on your histogram. So let's say that there's about 4 or 5 outliers because there are data points that are above 153. The lower fence would be 28 minus 1.5 times 50, which is negative 47. Would make any sense for campsites at state parks in Iowa to have less than negative 47 campsites. So there are approximately 4 outliers. As you could have seen on the histogram from this practice problem number 14, there's roughly 4 different campsites that have more than 153. There are approximately 4 state parks that have more than 153 campsites. So let's make a box plot for the data. We're going to go from 0 up to, let's call it 300. We'll go 100 and 200. Now our minimum was 0. Our maximum was 275. But I only want to draw my box plot out to the data point that is the highest non-outlier, which according to my upper fence was 153. So let's say we've got 153 right about here with the outliers there at 175, 200, and 225. 175, 200, and 225. I'm going to mark those with little asterisks or stars. Any outliers on the box plot are marked with little stars, asterisks, and I stop the box plot that I'm going to draw here in a second at the largest non-outlier value. So we've got our minimum, our maximum, the outliers. Let's go ahead and make the box plot by finishing up with the median and quartiles. So the median is about 43.5. 28 and 78 were the other lower and upper quartiles. So we'll draw those in and connect the box to the ends of the box and whisker plot. Lastly, we had to write a few sentences describing this distribution. So this is a significantly skewed distribution. And most campsites in the state of Iowa have somewhere between 28 and 78 campsites. Is a right or positively skewed distribution, with most state parks having anywhere between 28 and 78 campsites. Because this is a skewed distribution, we're going to use median and IQR to summarize the data set. All right, that should wrap up part 2 of Standard 4, summarizing quantitative data, where we've looked at using mean and standard deviation to summarize symmetric data and how to find those types of values, mean and standard deviation. We'll see you guys next time. Thank you.